Welcome to Science with Kanuj. Today I'll be explaining Igcse Physics 0625, topic 1.2 motion. So let's start. So this is the syllabus content. We will be covering about speed, velocity, the distance time graph, speed time graph, and we'll be also covering about acceleration. So let's start. Speed is distance traveled per unit time. The formula is v is equal to s over t, where v is the velocity, s is the displacement, and t is the time. And velocity is speed in a given direction. So this means speed is a scalar quantity because it only has magnitude, whereas velocity is a vector quantity because it has magnitude and direction. Now we have a formula for average speed, total distance traveled over total time taken. And here you can see the formula triangle as well. So you can use this formula triangle. So if for say you have to find the distance, so all you need to do is cover the distance d with your finger. So s and t, s into t. Okay, and if you have to find time, so then you can cover time with your finger, and then it would be d over s. So distance over time, distance over speed will give you the time. And similarly you can do with speed, so distance over time will give you the speed. Let's move on to the next slide. So distance time graphs. Now distance time graphs shows how the distance of an object varies with time. It also shows if the object is moving at a constant speed, how large or small the speed is. So a straight line represents constant speed in a distance time graph. Now let's see here, the green line over here, it is a straight line, which means it is a constant speed. And here as well, you can see the red line, it is beginning with a straight line, which is a constant speed. Then the slope of the straight line represents the magnitude of the speed. So as you can see, the green line is a very steep line, so it means it has a greater speed. That means it's a fast, the vehicle or the person is moving at a very fast speed. However, the red line is a bit shallow, has a bit shallow slope. It means that the object is moving at a smaller speed. And then when the line is horizontal, which means this part, it means that the object is stationary, it is not moving, it has the speed 0. Now the gradient of a distance time graph will give us the speed. So speed is equal to rise over run. Rise over run is basically the formula of the gradient, and the gradient is the speed when you the gradient of a distance time graph is a speed. Okay, and the yellow line we can see here, it shows that the object is slowing down, because you can see that the gradient is getting, that the speed has started from a higher it's decreasing the gradient. And here also you can see the blue line, it says that the speed is getting faster. It's because the gradient is getting larger every time, which means that the speed is getting larger. Let's move on to the next slide now. So next slide is about the speed time graph. Now speed time graph shows how the speed of a moving object varies with the time. It also shows if the object is moving with constant acceleration or deceleration, the magnitude of the acceleration or deceleration. So a straight line represents constant acceleration. So here in this graph, everywhere we can see that the object is moving with constant acceleration. Now here when the line is horizontal, when it is flat, it means that the object is moving at a constant speed. So it has 0 acceleration at that point. And when we can see here at the start, initially, the line is a bit shallow. However, after that it becomes a very steep straight line. So the steep slope means that it has a very large acceleration or deceleration. However, the shallow line shows that the speed that it has a smaller acceleration value. Okay. And then a straight line here represents constant acceleration, and here it is increasing acceleration. As you can see, the gradient is increasing at every point. So that means the acceleration is increasing, and here it is decreasing acceleration because the gradient has been decreasing at every point. Now area under a speed time graph will give the distance traveled. So for example, if you have to find the area under here, we can use the area of a triangle formula, half BH. We can take the value from here, the x-axis and the y-axis, and we use the formula and we can get the area under the graph, which would be giving the total distance which is traveled in that much time. And the gradient of the speed time graph will give us the acceleration. And increasing acceleration basically means that the acceleration is that the object is accelerating with an increasing rate. So first, let's say the acceleration was 3 meter per second square, then it increased to 5 meter per second square, then it increased to 7 meter per second square, which means that the acceleration is increasing. Okay. And now acceleration, this is only for the extended students. So acceleration is the rate of change of velocity. The formula is A is equal to V minus U by T. Now wherever we see the word rate in a definition, it surely means that time is in the denominator. So here, as we can see, rate of change of velocity. So change of velocity, which is V minus U over T. Now V here is the final speed, U is the initial speed, T is the time taken, and A is the acceleration. And this is the formula triangle. I have already told you how to use the formula triangle, so you can use it the same way. Now, an object that speeds up is accelerating and an object that slows down is decelerating. The acceleration of an object can be positive or negative depending on whether the object is speeding up or slowing down. So if an object is speeding up, it is positive acceleration, and if an object is slowing down, it is negative acceleration. Negative acceleration is same like deceleration. Sometimes we say it negative acceleration and sometimes we say it deceleration. Okay. And now acceleration of free fall. So in the absence of air resistance, all objects will fall with the same acceleration. It does not matter if someone has a greater mass or something has a greater mass, it will still have the same acceleration. And this acceleration of free fall is basically your gravity, which has the value of 9.8 meter per second square. Now we can use the symbol G is basically your gravitational field strength, and we can use it to calculate the weight of an object using its mass. So let's say something's mass is 70 kg. So when you multiply it with 9.8, we will get the weight of the object. Okay. Now this is the motion of falling objects. It's only for extended students. So when objects are falling without air resistance, I've already told that they will fall with the same acceleration. It does not matter regardless of their mass. So it does not matter what their masses are. And when the objects are falling with air resistance, initially the upwards air resistance is very small because the person, the skydiver, let's take an example here of the skydiver, isn't falling very quickly. So as the skydiver speeds up, air resistance increases, eventually growing large enough to balance the downwards weight force. So when both the air resistance and the weight gets equal, when they are balanced, the skydiver's acceleration will be 0 and it will move at a constant velocity, and this constant velocity is called the terminal velocity. Now after that, the skydiver opens the parachute. So when the skydiver opens the parachute, what happens is that the air resistance increases, and then the upward force of air resistance on the skydiver increases, and it slows the acceleration of the skydiver's fall. Eventually, the forces again balance out and a new slower terminal velocity is reached. Okay, and here is the graph of the object of the skydiver falling. So you can see initially it is falling with acceleration of 10 meter per second square. It reaches its first terminal velocity. The parachute is opened at this point, and there is a decrease in the velocity, a very steep decrease in the velocity, and it reaches then a second terminal velocity which is lower than the first terminal velocity, and then it reaches the ground. And here are the forces. So as you can see, initially what happens is the air resistance is smaller and the weight is larger. So what happens, the object accelerates, but when at a point the forces both become equal and they balance, and the skydiver falls with a constant velocity, the terminal velocity. Then the parachutist opens its parachute, the skydiver opens its parachute, and the air resistance becomes the larger force and the weight is smaller. So the skydiver starts to decelerate, and at some point again they reach a smaller value of terminal velocity. Again, that velocity will be a constant velocity, but it would be a smaller value than the first terminal velocity. So let's say if the first terminal velocity reached was 8 meter per second, so the second terminal velocity reached might be lower than that. It can be 7, 6, anything, but less than that. Okay. So that's the end of this video. Thank you so much for watching. Please like, share and subscribe for more such videos. I hope you understood the topic clearly.